This lecture video is going to talk about covalent bonds. So last week we talked about ionic bonds. So these are going to be bonds where one element gives another element its electron, and one element takes an electron from another element. And so the bonding that occurs when there's a give and take, an actual trading of electrons. Covalent bonds are going to be different. Covalent bonds are going to be bonds that are formed when two or more elements share electrons. So because both of the elements need electrons to be stable, they will actually share electrons because it's more efficient for them to share than it is for them to give or take electrons. So these elements are called covalent bonds. They're also called molecular bonds. So you'll see them written or named the same things. And like I said, these are going to be bonds where elements, two or more elements, are going to actually share the electrons instead of giving and taking. So like in this example right here, you can see we have two fluorines, and in between them, they're going to share the electrons between them. So the two dots represent electrons being shared. So, what elements use covalent bonds? Remember that last week when we talked about ionic bonds were formed between a metal and a nonmetal. Covalent bonds are formed between two nonmetals. Okay, so hydrogen is a nonmetal over here, but then remember this line, like you should have this line on your periodic table, and again, you're going to want to have that periodic table handy this week as you go through this. These were all the nonmetals, okay? So covalent bonds are going to involve bonding between these different elements here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're talking about compounds that include just those 15 elements. Now remember, these, your noble gases, they have a full outer shell. They have 8 valence electrons in them. So they don't typically they don't join with anything else because they're already full. They don't need to share. They don't need to get electrons to fill them up. Now remember, if you just count forward to see how many valence electrons you have, you got this column has 1, this column has 2, this column has 3, 4, 5, 6, 7, 8, right? And the goal for every element is to have 8 valence electrons in their outer shell. That is what makes a full outer shell. So if you look at nitrogen right here, nitrogen has 5 valence electrons. It needs to get to 8 in order to be happy, right? To be full and to be stable. And it could, if it was joining with one of these nonmetals, it can form an ionic bond, but really it would rather just share electrons with these other nonmetals in order to make itself stable. So what you're going to be doing is looking at how these form. Elements can share 1 electron with another element. Element can share 2, so that would be a double bond, or elements can share 3 electrons with another element. There's going to be a couple different assignments this week where it's going to ask you, here are 2 elements. Will they form a covalent bond or an ionic bond? And all you're going to do is you're going to look at each element. Are both elements nonmetals? Are they both over here? Then they're going to form a covalent bond. Is one of the elements metal, so over in this area, and then one a nonmetal, then it's going to form an ionic bond. So that's the first thing that you always need to do when you look at a compound, is look to see what category, metal or non, are the 2 elements, and then you're going to know whether it's a covalent or whether it's an ionic bond. Some general properties of covalent bonds. They have relatively low melting points and boiling points, and we'll talk more about those as we get into this course. Covalent compounds tend to be soft and relatively flexible. Remember, they're both nonmetals, so that would make a little bit of sense. They tend to be more flammable than ionic compounds. When they dissolve in water, they do not conduct electricity like ions and electrolytes do. And then many covalent compounds don't dissolve well in water at all.